Hello guys, today I'll be showing you how I made this Vellum dynamic stitching effect. We're gonna recreate this in the simple scene, then we're gonna dive into this exact Houdini scene and I'll be showing you how I made this step by step. Before we start, I should mention that you can get this exact Houdini scene file from my Gumroad page. This is gonna include all the rendering stuff, all the lights, cameras, and you can see how it was made. Of course, I'll be breaking this down later in the video, but if you want to get the project file itself, you can of course get this from my Gumroad. To start off, let's create geometry node. Let's use a planar patch. Let's set this to ZX. Size should be something like 6 by 5. Okay, that's fine. Let's adjust the edge length. This is going to be our resolution of the simulation. And this is going to be our patch, the cloth patch basically. Let's create some pin groups. Let's call this pins. This should be by edge and shard edges. Let's create Vellum cloth. And the parameters I found that is the stretch should be this one. Damping ratio 0.01. The bend constraints should be a lot lower, and then we're going to increase the rest angle scale just a tiny bit. Then we're going to create Vellum constraints again, and we're going to create those pin constraints so that our cloth patch stays in shape, in place I should say. So this should be pin to target, group type points. Let's select our points, and of course we don't want to permanently stitch this or pin this to this position. We want to have it a little bit of breathing room, let's say, and we'll set this to soft, and in here the parameters that I found that is 0.75, 0.01 in stretch, and then the bend is 0.01. That should work for us. Let's create Vellum solver node. Everything should be fine by default, except we're gonna turn off the wind, and we're gonna also turn off the gravity here. Inside of Vellum solver, before I do that, let's set this pin. Inside of the Vellum solver, let's create pop wind. This should be our basic wind effect. We want to set this to wind Y velocity to 0.35. Amplitude should be 0.5, 0.5. And the pulse length, this is basically the noise flow speed. So the bigger value, the slower the noise flow would be. So I set this to 4. Of course, with all the values you can play yourself. You can find the values that works for you the best. For me, that was it. So if you hit play, this is what we're gonna get. So we're gonna get a real nice cloth with a lot of like folds. So this is basically what I like. And those pin constraints actually pin this so it doesn't go infinitely high. Next up, what we're gonna do, we're gonna build the curve that would stitch this. Next step is the curve itself. Let's create our curve node. With this, we're gonna set the projection mode to geometry. We don't want to show guide geometry, and we also don't want any attributes that this node gives us. Okay, let's draw some basic curve here. And then again, the Houdini viewport is bagging, so it's just Houdini 20. Let's hit reset viewport, or if you don't have lamps, you can press reload current desktop. This should work as well. As you can see, this node doesn't give us evenly spaced points, and if we try to resample it with the subdivision mode, let's set this to something lower, so 0.35 for example, and as you can see, we got this jagged curve here. So to make it a little bit more smooth, we're gonna use resample before the final resample, and I'm gonna set to higher length here, so something like 0.25 or maybe even higher. And as you can see, it kinda smoothed out our curve. So let's draw one more, something like this maybe, and something like this. And as you can see, we end up with 3 curves. So this is going to be our out curve. Next step is to build attribute that will grow along these curves. To do that, we're gonna set to this final resample. We're gonna set this curve view attribute, and we're gonna create attribute swap here. With this attribute swap, let's dive inside. Let's create fit range. Let's take our frame, and I'm gonna remap this frame attribute. So our growing should start at frame 20 and maybe go into like frame 60. And let's output this with the bind export to a mask attribute. And we can visualize this attribute with the color node. This is the way that I do this. And then I set this to infrared so I can get more informative visualization here. So if you hit press, you can see from frame 20 it starts growing, but of course this effect is just plain because we haven't introduced any offset yet. So let's do that, and this offset of course is going to be our curve U attribute. So we're gonna use a bind node, we're gonna import curve U, and then we're gonna subtract it from this frame. And of course by default nothing is changed because this frame it's not, so this curve view is from 0 to 1, but this frame is from 1 to like 250 basically. So that's why we're going to use multiply constant node, and this multiply is going to be how many offset frames should we have. In my case it's like something like 40 should work fine. And as you can see, basically we get this kind of growing effect here. We're gonna have another fit range after this fit node, and this fit range should allow us to control the follow width here. And of course I don't want this curve to grow evenly between all of them. As you can see, they all start growing and end growing in the same frame. That's why we're gonna do something a little bit fun here. Let's take primnum, let's say integer to float, let's duplicate this and take the num prim here. And if we divide this, we should get for each of those curves we should get evenly spaced value, if you can, as you can see here. So the problem with this random node is that it tends to output similar values here. As you can see, those two curves have plus minus the same value, and if you do this way, they all have different values. And if you copy this multiply node here and then pipe this into subtract node, let's get our fit range back to mask. And now as you can see, they all have different offset. And of course we're gonna just lower this, something like 20 should be fine here. As you can see, they all start growing. This is basically what we want. We're gonna call this grow attribute mask, and this is going to be it for the mask. Next up, what we need to do is we need to transfer this back to our constraints. So the constraints that we're gonna affect is the stretch constraints. So let's select let's visualize only the stretch constraints. So delete all but stretch, and then we're gonna copy this mask. So this way we can visualize this. This sets us to primitive. Those are not imported nodes. This is just for visualization. Let's create another VOP here. By the way, I changed this class from point to primitive because every constraint attribute exists on primitives, of course. So that way, let's set this to transfer mask to constraints. Let's pipe this to second input. Inside of this node, we're going to use a import point attribute from the second input, and this actually requires point number, and we're gonna sample the nearest points to the curve with the near point function. And of course the attribute that we want to import is the mask here. Okay, let's visualize this, and of course we're gonna bind export this to mask, and if you hit play we get nothing here because of course you have to set this VOP run over primitives. We're getting something, and of course we want to only run this over stretch constraints. So this is something strange here. The reason is that all the points have near points, right? Somehow we want to isolate this effect to exist only near curve primitives. For this we're gonna duplicate the import point attribute. We're gonna set this back to vector 3, and we're gonna say we want to import point positions of the curve, and then we're gonna calculate the distance between the all primitives to the curve point positions. Let's use fit range to remap it, and if we visualize this is exactly what we want, but we want the inverse of this, and we want to adjust this a little bit. So something like this should be fine. Okay, something like this. And of course this is not growing at all because we still want our mask, but we want this mask to multiply. So basically we create a mask for this mask, and voila, this is exactly what we want. Next step would be actually to dynamically adjust the rest length of the stretch constraint. Let's visualize after the solve, and as you can see we got nothing. The reason is because this Vellum doesn't update attributes. It only takes the start frame and then does its job. That's it. So somehow we want to transfer this back. For this we're going to use subsolver, and this subsolver should by default runs over the geometry, which is the first input. We want this to run over constraint geometry. So let's call this constraint geometry, and let's dive inside. Okay, so we're not use attribute copy here because we already transferred this, so we want this just copy, basically update each frame. Let's take this null, or you can just create a new one, doesn't matter, and let's call this constraints. Okay, I'm gonna hit Ctrl C. I'm gonna copy this. Let's dive inside. Let's create a node called object merge, and we're gonna just Ctrl V here. And we'll basically, if you untick this button, you can see that we just copied this geometry back. So what we want to do to this dop geometry right, which is updating every frame, we want to copy the mask back to it. So we're gonna do mask, and this is of course primitive attributes, and let's see the result. And yeah, the result is bad because for some reason in the first frame it doesn't create all constraints, or I don't know how it works, to be honest, but this doesn't work. I believe that's because of this pin constraints that we have here. Maybe if we give it a different, like, pin groups, let's say pin S, and then let's say pin B, maybe now it's gonna work. No, it doesn't work. So that's not the case. I don't know why, but it doesn't work. The fix that I found that is we just create enumerate node. What it does, it just gives a unique index attribute for each primitive, and if we copy using this index, it works perfectly. Yeah, there you go. So we still have our animated geometry, but the constraints now have a dynamic mask attribute. So for this mask attribute, we're gonna, again, let's pin this. This is again Houdini 20 viewport bug, another one of them. Okay, let's create Vellum constraint properties. This node should allow us to dynamically change the constraint properties. We're going to change the constraint properties of the stretch constraints, and the property that we need is the rest length scale. So let's type rest scale equals 1, and of course nothing is going to happen. But if we start to, for example, let's say 0.5, what should be, as you can see, the cloth becomes 2 times smaller because we are adjusting the stretch constraints. So we want to do that using our mask attribute. So we're going to say multiply equals. So we're going to take this as a main value, and then we're going to multiply this main value by the mask. So before we type our mask, we're going to type fit range. So we're going to basically remap this. So fit 01, because our mask starts from 0 to goes to 1. And then what we need to do is we need to invert our mask. So 1 minus mask, and then if you hit 0 and 1, basically what's gonna do, where the mask exists, it's gonna be 0, where it's not, it's going to be 1. And of course this is not gonna work properly, or it kinda does, but what we need to do, we don't want this to set to 0, we just want something a little bit lower, something like this. And if you watch, so yeah, this is basically this exact effect that I showed you. Right now we want to, of course, if you merge this with the curve itself, of course the curve is not updating. What we need to do, we could use point deform, but I found that using the ray node works a little bit better for me. So we're gonna use ray node. We're gonna store all the hit attributes. So basically where this curve exists on the patch primitives. So let's take this hit prim and hit prim UV. Let's untick transform points, and then the method should be minimum distance. So basically storing hit attributes, right? And then we're gonna basically attribute interpolate using those hit. So if we connect, basically it's gonna just do this. Let's just adjust this. So this is out Vellum solve, right? Okay, so the interpolate doesn't work because we need to select our hit prim and hit prim UV. And as you can see, now it perfectly follows our cloth here, as you can see. Let's create sweep, round tube, and then if we look, it's quite low because we are interpolating basically everything. We don't want to do that. We just want position here. Now let's of course make it a lot smaller and maybe select the end caps. We can also attribute blur it, untick the border points, and let's set this to something like 2. And basically that's it. If we want to adjust the P scale, we can easily do that as well. If you want to have spirals here, what you can do is you can have sweep node. Let's set this to round tube. Let's set this to 1. Let's create a wrangle. Let's set P scale. And inside the wrangle we're going to type P scale equals 0.025. This is like a main scale, and then we're going to multiply this scale with our mask attribute. So we're going to start by 5, go to 1. And if you look, what's happening is that if you switch this to columns, let's set, for example, 4 of them, and then with this you can set this to per edge, and then let's just twist this like this. So it's gonna start big, then it's gonna slowly transform into thinner curve. And we're gonna also adjust the roll effect also with the wrangle. So let's set roll, and then the basic roll should be our curve view, and I'm gonna multiply this by maybe 25. Okay, so if you set the scale by attribute roll, this is maybe okay, so it's roll. Oh, okay, so we have to set this, of course, roll, and then I'm gonna roll. Okay, that's so yeah, this is what we get. And as you can see, they are different because they have different primitive lengths. What we need to do is we can over here, before we actually grow attribute, we can just put down the measure node, switch this to perimeter, and then we can say curve length. Okay, so this is going to be our curve length. And then with this here, we can introduce another variable. We're gonna get from primitives, we're gonna get our curve length here. And so I just forgot. And as you can see now, they're all the same roll. And then you can make this variable as well, the parameter, sorry, here as well. So that's it. So if you now look at the animation, it's all good. Okay, also what we want to do is we want to lerp this. So we want to lerp from roll to roll multiplied by 0.95, for example. And for the mask, we're going to use our mask attribute. And as you can see, what's going to happen is it's just going to transform from like a higher roll to lower, as you can see. And then with this sweep node, of course, we want to make geometries out of this. And yeah, you get this, as you can see. And then you can adjust the radius. Alright, so you have to find the balance here, of course, but if you look, color, let's just have something to differentiate them. There you go. What you need to do is, before this second sweep node, you just need to say add p scale, multiplied equals add mask. Or you just have to invert this again. Maybe. Oh, wait. So we'll get this. Oh, of course we don't get any p scale here. So our p scale basically should be the radius here. So we're just going to say just equals, and then we're gonna just adjust the p scale. So this mask, it was fine before, and then let's make this a lot smaller, something like this, and there you go. And what I did was, again, I just used the attribute remap sub, and I just remapped mask here, something like this, and this is what you get. There you go. Also, you can drop down the orientation along curve. This should give a little bit better job for the sweep node in order to maintain the geometry. So this is basically the basic effect. Now let's break down the global scene that I showed you. We're going to start off breaking down this scene file. I just imported the logo. I used the OD tools vector import node for this. You can also do it with the file node. You just have to properly set up in the Illustrator or whatever program you're using. So after the importing, what I get this like 4 pieces, and what I did was I just blast them one by one, as you can see. And what I did was I just cut one from the another, so I get something like this in the end. Only thing that I didn't cut is this piece, the last one. So I get this 4 individual geometries. Next up, I transformed it. I cleaned all the attributes, gave it the UVs. I then promoted the color from primitives to point. So this is basically our logo shape. Next up, what I did was I merge the logo shape here, and I work for each shape. I created those stitches. You can't see them right now, but the way it works is that I use divide node to remove sharp edges, and then I use convert line, and I basically manually select this like top parts, and I use polypath to join the curve back. So in the end I got 2 curves, and then with the split node I just say split like one of them. This way I got like 2 different geos. And then this num of threads resample node basically allows me to set the amount of threads that I'll be getting in this geometry. So I did the same thing for each of them. The only exception should be this one, those guys. What I did was here I just cut out those stitches from the main pattern, and I gave them also the weight attribute here. So this is my stitched lines here basically. Then what I did was I jittered those points using basic vex expressions, and what I had was something like this, as you can see. I also resampled them and gave it them curve view attribute. Then I again get my static geometry, static patch. I stored the same way that I showed you before. Hit attributes, gave it the rest, and I also gave it random width attributes. So basically the width of those hair strips. and then I use this distance from target node. I'll basically set in this from the left upper corner. For this I used these expressions here, and this basically give me the distance from this point all the way here. And then the same way I showed it before, this is growing mask here. If you visualize this, this is how it looks. Right now we want to go back to our mesh here. What I did was I just get geometry here, not these stitch lines, and then here I just subdivide this using loop algorithm. Do the same mask, so I basically copied this from here to here. I get the same growing mask. As you can see, nothing is changed. And then if we look here, this same setup, like exact same really. If we look here, the same nodes, they are just named properly. And then what I get something like this. As you can see, if you visualize the mask. Okay, so this again Houdini. Okay, so this is the mask on constraints, and this is what we get. The only thing that I did here, I used point deform. I basically had this static quad grid, as you can see, and I deformed this vellum because I don't want triangles in the final render, because if you resample, if you subdivide the triangles, you get this weird artifacts here. I didn't like them at all. That's why I used a point deform to deform the static quad geometry, and I'll also gave it a UVs, of course. And this is my render cloth geometry. So if we go back here, again store hits, randomized width, and then I used the same attribute interpolate. As you can see, this works the same way. And with this node I used this displace node. What I'm saying here is I just want to distort every hair that is not affected with this mask. So when the mask comes, they slowly go to shape, as you can see. And here is the logic. I'm not gonna go through each node, but basically here I'm just displacing this by this like ramped values. Then I'm offsetting the dots, as you can see, these ones. If you go last frame, you can see them. I use this weight attribute that I set up before, and I basically displace them. And then this is distort by mask. This is basically adding this noise effect. So that's basically, as you can see, how it works. And I add also a jitter to those strains, and I also multiply the width by mask. So here it is, just multiplication, and I promote color for rendering purposes because Redshift needs primitives. Clean attributes, and this is my render needs here. For this cloth I also created the hairs. If I visualize them, you can see this is the hairs. What I did here, I created this basic volume noise vector using the bounds from those quads, setting up the velocity, activating those velocities by those bounds, and then basically setting the velocity vector. If we use hair generate node, as you can see, it's almost by default, you're gonna get this straight up hairs. So if you use guided vec node, as you can see, it just nicely organically distort those. Added some frizz, added some clamping, used a curling a little bit, and then I used a guide masking by random. And what I did was, for those masked geometry, I basically set those hairs a little bit longer, and I also freeze them a little bit, and I globally randomize their width, and I use guide deform to basically deform this with the animated cloth, and that's pretty much it. For rendering, it's quite simple. I have my cameras, I have those adjustments that I did here, I have my lights. So if we turn them off, first one is just the key light, actually it's a fill light. Then I use the sun. It just gives this, as you can see here, some like fill light as well. And this is the main light. It just like gobo lightning from the top. I had this 3 object nodes. First one is just the cloth with the tessellation, then the knitting. With this I just selected the render polygon as hair, match Houdini mantra hair thickness, and then this cloth hairs, as you can see, it's turned off. But if we go our redshift here in the objects tab, I turned off the candidate objects and just forced every object that has RNDR before, like prefix. Basically, I only get those little hairs in my render. That's what I'm saying here. With the shader, everything is simple, just standard shader. Just use some bump map with this cloth. It's not even displacement. With the knitting, what I'm doing here, I'm just bringing in the color from the geometry, just desaturating them. And I also used this random hair node. What I did with this is I just used this random values, just to have a little bit of hue shift between those curves, just to give this a little bit more detail. And then what I did was I took the original color, I desaturated it a lot, and then using this again, this random value, I just remapped this, and I basically had this stray hairs here. And with that, basically here's the settings, and this is what we'll get at the end. So that's basically it for rendering. That's it for this tutorial. I hope you find it useful. As you can see, this is my setup, my final setup. As you can see, they are just nicely growing here. And again, this same setup that I showed you. Nothing is new here basically.